idea of this presentation starts, of course, from working on some mapping projects for my college. After I joined Milwaukee Area Technical College last year in the IR office, I was assigned to a couple mapping projects, in particular to help the college's administrators to see the distribution of our students. So today's presentation, I would like to show you some of the projects that I've been working on. But to start with that, I would like to give you a little bit introduction to GIS. So if you don't have any experience with GIS before, you can have some ideas, some basic ideas about what GIS is. So start with that. So what exactly is GIS? So first of all, GIS stands for Geographic Information System, or science. As you can see here, GIS can be easily described as a system or science that deal with geographic information, but probably not quite straightforward. You're probably still kind of confusing, not quite sure what exactly that is. Actually, there are many different definitions of GIS. When you ask different people, they may give you different definition of GIS. And it will depends on how you are going to use GIS. GIS can be viewed as a database for geographic information, a set of tools, softwares to manipulate geographic information. It can also be a set of analysis methods to analyze geographic information, or there can be a way to present the geographic information. But all of this and many other definitions of GIS basically touched on one of these 6 major components. As you can see in the image here on the screen, GIS involves hardware and software to store data, and also people will need to develop a set of procedures and identify appropriate methods, models from the softwares to manipulate and analyze the data stored in the database. And all of these components can be linked together by network, including using network to obtain data and also to distribute the results. So you may already notice that I mentioned several times of geographic information. So basically, geographic information makes GIS unique from other fields. And so GIS can also be defined as an industry working with spatial data or geospatial data. So that's another term trying to confuse you. So what is spatial data? Well, here is a definition for spatial data. It's information about the location and shapes of geographic features and the relationships between them, usually stored as coordinates and topology. So it's probably even further confuse you by this definition. So to put it in an easier way about spatial data, it is any data that can be mapped on a map. Usually that means the data has to have a geographic location, a coordinate or an address, or there can be a zip code numbers or cities names, whatever can describe a location, so that you can pinpoint that data somewhere on the map. When you have quite a number of locations plotted on the map, then you will be able to analyze such as the distributions and their relationships among each other. So in GIS, spatial data are stored in map layers. So a map layer can show such as city boundaries, a layer can show such as university locations, and they can also show such as student addresses, for example. So you will be able to put all those map layers, all those informations on top of each other based on locations. And with different spatial data overlap to each other, further analysis can be performed, such as which and how many students live in the city boundaries, or how many of them live within certain distance from your institution. So now we have spatial data where locations able to identify and mapped on the map. We also know we do have some data probably not that quite able to directly link to a location. So for example, we have student GPA, students, credit hours, those informations, they're probably not directly associated with a location, but we can link those data to a student's ID, and the student's ID can link to the student's home address, and then we will be able to map those informations, the non-geographic information, to a map. And all those informations, spatial information, non-spatial information, they can be all saved in an attribute table. And the attribute tables can be linked to the map. So that means you can use whatever information you have in the table to change your map. You can color your map based on the GPA. You can color your map, or change the symbol on your map based on the credit hours taken by each student. And also you can perform some queries, searching information in your tables, find like which students took more than 10 credit hours during the semesters, and have those records highlighted on the map. So in GIS, you will be able to do that because all those informations in the tables are linked to the map, so you can perform that kind of analysis. So, in GIS, you can interact with the maps and the data in the tables. And so in the traditional way, you may print out a map as a paper map. And well, that's, although we think paper map probably not that good enough, but it do have advantage of using paper map. But once you print out information on a paper, you will not be able to add or remove information from that. That's pretty much what you have printed, that's what you have. And so in GIS, on the other hand, you will be able to make the map interactive. So GIS can give you flexibilities while on creating paper maps. So in GIS, yes, we do create paper maps after a series of analysis and manipulations. But more powerful in GIS is that you can just keep using the map in the softwares or distribute the maps online in the internet. So that can be a dynamic way to distribute your results. So in GIS, map can be dynamic, map can be interactive. That means I believe many of you, or almost all of you, should have experience using Google Maps. So Google Maps is one of good examples to introduce GIS to someone without a lot of experience in GIS. So in Google Maps, it shows you the map can be interactive. You can zoom and pan the map at different scales and target at different areas. And you can have additional information displayed by adding locations or search to get information from the data table behind the map. So Google Maps is one of the examples of interactive map, showing the dynamic of the data, the information in GIS. So, okay, so that's now pretty much what I want to talk about introductions to GIS, and that will also relate to what I'm going to show you in a minute about the examples. So now it's time to look at some examples. So to start a GIS project, you of course will need to have data in hardware, in softwares to run the analysis. So here's some, I want to point out the data and softwares I've been using. The data, especially for the projects I'm working on in the examples that I'm going to show you, are mostly from our institution's database. That will include the school information, students' information, that will basically from the college's database. And sometimes you will also need to compare your students' information, your college's information to the general population, population's demographics information, for example. So that kind of information you will be able to obtain from some public agencies such as U.S. Census Bureau, and sometimes you can also obtain the information from your local government. And another data source I would like to point out is you probably can try to reach out to GIS libraries in your region, in your area. Like for my examples, I reach out to the GIS library located in University of Wisconsin-Milwaukee. The library is in our areas, and that means they should deal with a lot of information, GIS data, GIS information, especially for Wisconsin, Milwaukee area. So that will be very helpful because when you go to find the data at a federal level, agencies, they probably don't have detailed information about your area. So you will probably want to reach out to your local agencies or local libraries to get data if you are more interested in analyzing information in your local area. And so that's about data. And for software, I mainly use products from I-Hui that include the desktop and online versions. The reason why I use I-Hui's products, one, because I am personally more familiar with their products, and second, because my college do have the license of their product. So if you do have a license of their product in your institutions, there will definitely one software you can think about. And there's many other softwares out there you can try. But some of the software may cost a lot. So that's one issue. So if you don't want to pay that much money to purchase the license for the softwares, there's also some free open source options such as QGIS. So you can use the tools, the GIS tools from them to do some analysis and to give it a first try and see if you want to purchase a license from other software companies. So that's the software is about GIS. So now the first map I would like to show you is to give you some background about my college, MATC Milwaukee Area Technical College. So Milwaukee Area Technical College, MATC, is a public 2-year technical college located at southeast of Wisconsin. So on this map, you can see this is the school district. And the school district covers the entire, well, I will need to zoom in a little bit so you can see information. Oops, too much. Okay, so the school district covers entire Milwaukee counties and also most of the Ozaukee County and also southeast part of Washington County and a little bit tiny portion of Waukesha County. And our college also has 4 campus. So the main campus, the major campus is the Milwaukee campus located at downtown city Milwaukee. And we also have the West Alley campus located at the west part of the district. And also the south campus is the Oak Creek campus. And we have a north campus in Mequon. Okay, so this is a little bit background about the location of our college. So now this map shows you the distribution of our students. in the semester of fall 2016. So this map shows you the distribution of the students, showing that you should be able to see most of the students are from Wisconsin, so, and followed by Illinois. And, well, we have one student from Alaska. Because MATC is kind of local college, so we don't have a lot of students from out of state. But if your institution is more like regional or national level college, university, then you will probably, the state level map will be able to help you to see the distribution because you will have more students from out of state. And even if you have a lot of students from international, then you will probably want to map also those students. So to see maybe this distribution, which continents most of students coming from, or you may want to see some changes of those regions of those students. So this is a state level map showing student distribution. But when you are dealing with map with geographic information, sometimes we will need to realize generalization can be misleading. Because now when we look at this map, we see many of the students, our students from Wisconsin, but those students' locations not evenly distributed across the state. So somehow we will need to lower down to see a smaller scale map to see some differences in the local area. So here is the map, the same set of students at county levels. So, so here you will see on this map, the small one here on the top, it will show you inside state of Wisconsin, we have most of the students from the southeast counties. And that's reasonable because that's where MATC located. And here you will see the numbers showing that most of the students are from Milwaukee counties and not that many from Washington counties from this map. So this is a map showing student distribution based on county level. And probably not quite good enough for MATC. So we move further to go down to zip code level. So this map shows you, again, the same set of students enrolled in fall 2016, but map those students' locations based on zip code. So now here further shows you the distribution of students. And from this map, you will be able to see most of the students concentrate at south of downtown Milwaukee and also a bit north of downtown Milwaukee. So, so that will kind of help us to understand where are most of our students coming from, show more differences in a local level. And you will also see that from this map in both of the two previous maps, the county level maps, we don't have that many students from the north part of our district. So this free map just want to show you that you can map your information, your data at different scales, and that will kind of serve in different purposes. And if you would like to see the differences at local levels, you will need to pick up an appropriate unit to map your data. Okay, and so that's just the map showing one semester of students. And sometimes you can use the same method to map student distributions for different semesters. So you can have them side by side to compare if there's any differences between different semesters. So like this map shows you 3 semesters of students distribution: summer 2016, fall 2016, and spring 2017. So it's kind of quite consistent, showing us that from this map, we have quite a low enrollment, again, from the north part of the district. And so that shows a similar results showing that most of the students from the central Milwaukee County area. So that's even summers when there's not many students enrolled, typically still most of the students from that area. So those are the maps shows you the information that's printed out as a PDF file. So that's pretty much like a paper map I mentioned earlier. It's static. So you cannot change, you cannot zoom in, zoom out the map to see further information. You cannot click on it to get attribute information to see what exactly the enrollment count for each zip code. So, and you can try to put those numbers on the maps, but it will be kind of noisy because some of the zip codes, especially in the downtown Milwaukee areas, the zip code is kind of small in this area. So when you want to put those attribute information, the number of enrollment counts, for example, those numbers will probably too close to each other and not that easy to read, and you will not be able to get a clean map to show other people. So that's one of the disadvantage of using a static paper map. So now here I would like to show you another way to do the map presentation, which is by using interactive map. So this interactive map shows you 4 small maps. So I compared students' enrollment, student distributions in fall 2017 and fall 2012. So you can compare student distributions in the same semesters but in 2 different years. So same thing here on the right-hand side, you will see student distributions in spring 2017 and student distributions in spring 2012. So here you will be able to see them side by side to see, well, that's the change of student distribution over time. And so now here, for example, if we compare the fall 2017 map with fall 2012 map, for example, here, this area close to our North Macon campus, we have quite low enrollments in this zip code area. So somehow you will wonder what exactly is the enrollment numbers and what other information we will be able to obtain in order to get some more idea about the characteristics in this area. So the advantage of using interactive map, not just because you can move the map around or zoom in, zoom out the map, but also by using interactive map, you can click on the map and it will show you the attribute information of the features on the map. So for example, now here, if I click on both on the zip codes, same zip code areas in both maps, then I will see the attribute information for that specific zip code. So I will be able to see the exact enrollment count for that zip code in 2017, which is 39, and it was 52 in fall 2012. So that's a decrease in enrollment. And you can also see other demographic information if you do have that information in your database. So here's a compare of student demographics in terms of gender. So we have the gender females and the male population, male students is a majority, and it's kind of decreased the percentage over time. And we also have student demographics in terms of race, ethnicity. So we have in this zip code, we have the white students decreased over time from 2012 to 2017. So that's another information to add to understand this zip code area. And also here it shows you the age groups distributions in the zip code area in terms of for our students. So the average age and also the percentage of age, the percentage of population in age 18 to 34, which is our major student age groups. So those are the advantage of using interactive maps when you show people maps about such as the distributions of students, you can also query to find further information to support your analysis. Okay, so this is example of interactive maps showing maps in different years to compare it. And here is another map shows you the examples to show you the distribution of population growth rate in age 18 to 34. Again, this is our major student age group. So we want to know which zip code has this group of population increased and compare that to our students. So here in this map, let me turn on the legends so you will see. So here, those polygons here, those areas here shows you the general populations. So here is from census, this is the populations in age 18 to 34. So the darker red color shows you the higher percentage of increase in this group of populations. And the blue color shows you a huge decrease of population in this group. And the bubble here shows you our students' body. So again, same thing, the larger the bubble, the darker the red color is, shows that zip code has increase in students in age 18 to 34. And the blue color, smaller bubble shows you the decrease in students in age 18 to 34. So from this map, you will be able to compare it to find out, for example, this area we have the general population from the census. This area, the zip code, do have more population in age 18 to 34 from 2010 to 2015, but the bubble shows you that our students in these age groups kind of decreased over time. So it probably will be the area you want to go into to do some further studies, why the area has more our potential students, that population growing, but we don't recruit that much students from that area. So they kind of give us some compare about the general population's demographics and our students' demographics. And so, okay, and here this map is another example to show you where we might be able to find potential students. So here this map, the purple bubbles shows you 2016 public high school enrollment on the 12th grader, and we will be able to compare that with our MATC students who enrolled in, for example, fall 2017. So the larger the bubble shows more 12th grade students enrolled in public high schools in 2016, so which will graduate in 2017 can be possibly our new students next year, well, this year actually. So that will be the area we want to focus on. And so, for example, this light yellow color area, that is the area we have low enrollment currently. But we do have the bubble here shows you kind of mid-size bubble shows have, if you click on that bubble to show the detailed information, that shows we do have 292 high school 12th graders enrolled currently in the high school. So that probably will be the area we want to send our recruiters to reach out to that school to find out if we can have more students enrolled from that high schools. So same thing in those areas, traditionally we have a low enrollment from that area, but this high school has a lot of enrollment, high enrollment in 2016, which here shows that 370 12th graders enrolled in 2016 in this high school. So we may want to send out someone to there and to try to recruit those students for this 2017 year. So here is another example to show you can compare your student current enrollment information with potential students, such as those currently enrolled in public high schools. And here is another example, another project I've been working on. This project is to look at students who enrolled in nursing program courses. Currently, we do have nursing program courses offered in 2 campuses. One is the Milwaukee campus, another is the Macon campus. So this project was requested by the Dean of College of Health, and she wants to know if they need to offer more classes in those 2 campuses, or they will need to open up new courses in other campuses. So from this map, especially the one on the left-hand side, shows you students who took student location, home address for those students who took courses in Milwaukee campus. This map shows you that many of them actually live quite close to the 2 other campuses, the West LA campus and also the Oak Creek campus. So that's on the purpose of this project. We may be able to suggest the dean saying that, well, if it's possible, you may want to open up new courses, offer courses in the 2 campuses, because you have lots of students from that 2 areas taking nursing courses. So this is an example shows you by studying the distribution of students based on the location where they took the courses, you can suggest kind of the redistribution of your resources, offering courses in different campuses, for example. And here is another in the final examples I want to show you. This is examples shows you to find a facility for some events. So this is a request about the program managers wants to find out how many students will be able to serve if they hold in orientations events in city libraries. So they want to have the orientations, and they want to have the program applicants able to attend orientations in their local city libraries. So here on this map, you will see those blue colored symbols represent the location of city libraries, and the yellow orangish bubbles shows you the location of those program applicants. So this is the background, and I would like to show you the next map. By performing an analysis in GIS, it will show you they will assign those students to the nearest location, the nearest library location. And the number shows you how many students are nearest to each of the libraries. So for example, this one here shows you there are 234 students close to this library. And so you will be able to see the colors again because the information is linked to the map features, so you will be able to color those students in different colors based on which library mostly close to them. So here, more importantly, here from this map, I would like to point out that it will also show you those students marked as red triangles. Those are the students, they are kind of far away from any of the library. The cutoff distance I selected was set to be 3 miles. So that means those triangle locations are the students who are far away from any of the libraries more than 3 miles. And another thing I want to point out that after you have the result like this, you can also look at some areas like this 3 library, kind of serves relatively low students if we want to include them. So sometimes we probably want to save the resources. We don't want to have the events in every single location if there's not that many people going to attend. So we will rerun the analysis by removing this 3 locations to see if any applicants not able to serve if any of the numbers increased. So we removed these 3 locations and rerun analysis, and we find out, well, that same set of students not able to be served, and there's no additional students in those areas not able to be served by a nearby library. So, so this is another example to show you how to help your institutions to find out location to serve your students based on location and distance. So that's all examples I want to share with you at this point. To conclude, well, I've already shown you some examples using GIS to study some topics I are dealing with. And so in GIS, as I mentioned, there are different ways you can do to present your data, especially you can use interactive maps to show the information. The reason why I'm quite interested in using interactive maps now because at the beginning when I was working on the project for my college, I was using the paper map to showing the information. And as I mentioned, it sometimes can be kind of not able to show a clean map with a lot of information. So interactive map is one way to show a clean map with just the colors at the beginnings. And if you would like to know more detailed information about each individual location on your map, you can simply zoom in to see more further information, or you can click to get attribute information pop up in the pop-up window, so it won't block the information on your map. So, so that's one of something I would like to mention based on my experience by working on the projects in my college. And another thing I want to mention is that the softwares is one of the issues. The data is another one. Well, when we learn about GIS, everyone will keep telling you the most of the time and money you are going to spend is on the data and the software. For now, because most of our data are from our college, so it was okay for data. We are not yet need to purchase lots of data. So the cost for data is still low at this point. But the softwares, you will need to pay for the softwares, and especially if you would like to use interactive map, which means you may need to push your data onto the vendor server online, and some of the vendors, they charge for those data you put on the internet. So that's an additional cost you will need to consider. So that can be kind of expensive if you would like to use a vendor software to do your project. So that's another issue you need to keep in mind when working on the GIS project. So I think that's pretty much what I want to talk about. Again, thank you very much for your attention today. And any questions or comments?
I-Hui, this is May. Very nice presentation. Thank you very much.
Thank you.
Yeah, I think this is the open eyes for most IRs because we do not have the background you have right now.
Well, yeah, I pretty much go through those examples pretty fast. But I will attending the AIR conference at the end of this month. So if anyone interested in seeing some demonstrations, like how to perform certain tools or functions in GIS, I would be happy to do that. If anyone going to the AIR forum?
Yeah, I think a lot of
I will.
Yeah, so just feel free to contact me. Let me know if you would like to meet up to have further discussions or want to see some examples, I would be happy to do so.
Great. Do you use SAS Visual Analytics or Tableau right now in your office?
We don't, but I am quite interested in Tableau. The demonstrations we had a few weeks ago, it's kind of interesting to have. Actually, the software Asterisk products I'm using now, they do also have something similar to Tableau. You can install the in functions in Excel. So you can do the maps directly in Excel. So that's pretty much like what the vendor showed us a couple weeks ago about Tableau.
Very nice. Okay, everybody, if you have any questions, you can post on the chat box or just speak out directly. Any questions?
Yes, so this is Lucy. I have a question regarding, have you ever tried to use the census data that they have a demographic information such as race, income level, that kind of information to merge into your map?
Yep. Well, actually, the one I showed, this one, the age groups. This map, I was using the students' demographics and also the information from the census.
Okay, because there's a problem. Census is using the census blocks, and then because our students we geocoding the student into using their zip code, so we know their zip code. And then I'm wondering if you have any information is like demographic information by zip code, such as education attainment, income level.
Right. From Census Bureau, no, they don't have, because that's a difference between the Census Bureau, they use the zip code tabular area, and that's different from the USPS zip code, because they believe the USPS zip code is not real physical boundaries you can map on the map. So all the census, they are based on the geographic units, which is the one they are using. And so if you would like to use the census data from Census Bureau, you will need to do some calculations to convert that zip code tabular area data to the USPS zip code boundaries. U.S. Census Bureau, I don't think they released any official crosswork to do the calculations, but I was using, there's a crosswork I found from HUD, House and Development Department. That's an official federal level agency, so it's relatively reliable. I can give you the link to that website. So they do have the crosswork help you to merge census tract to USPS zip code.
Oh, that
so
would
you
be
can
great.
get the data from the census tract label and then merge those census tract to the zip code.
Yeah, I do using the thing is we need the zip code by their information like this education, income level, race information, age information. If there's any tables by zip code, that would be great if you come across that kind of information. Right,
but yeah, I don't think the U.S. Census Bureau they provide the kind of information, but they do have the census tract label data, so you can just use that crosswork to do the calculations.
Oh,
yes,
okay,
you can
just
do that.
Join the layer. Is that what you mean?
That's the crosswork is Excel files, so they will tell you the portion of each census tract belong to which zip code. So you will use that the value, the portions, like let's 40% of the census tract go to zip code 101. So you will multiply the portion with the demographic information, like total population in the census tract, and then combine all the census tract in zip code 101 to get the final numbers for that zip code 101.
Okay.
Yeah, I can show you that. I can send you the link, and that's to have the instructions in the website to show you how to use the coursework.
Oh, yes, thank you. Would you please?
Sure. Yeah, so you will probably need to send me an email or something so I know your contact and will be able to send you that information.
Okay, Dr. Lin, there are two questions posted in the chat box.
Okay.
One is ask you to estimate cost for this software. Along this one, I tried to see, we did not have any technical background. Is it possible or easier to learn this, how to use it?
Okay, so for the first question, the cost of the softwares, because I'm not in charge in purchasing the license, I'm not very sure the exact numbers, but I do know that for university education institutions, nonprofit organizations, we will be able to purchase a discount license. And it will also depend on the size of your organization, your institutions. So that will depend on how many students in your institutions, how many people are going to use the license. That will be cheaper if there's only one person using the license, and that also means you can only install the software in one single computer, for example, or only one person can use the software at one time. So if you want to have many different people using the softwares, creating different accounts for your, in your institutions, that will add up the cost. So you will need to contact the representative of the vendor, so they will do the calculations and give you the quote.
This is Yan, also from Milwaukee Area Technical College. I work in the same office as Dr. Lin. I can answer this question because I purchased this software for my office.
Thank you, Yan.
Yes. It's about, right now we purchased the license called Concurrent. So we can have multiple users, but we cannot have multiple users using the software at the same time. So it's basically one user, but multiple people can use it. It's less than $300 per year. But we are using the desktop one, not the one that that's interactive. So I don't know how much that's going to cost.
Can we read the menu and learn how to use it by ourselves?
Right. So that question's, I think the L3, the companies for the software that I'm using, they are trying to make some web applications in really easy for some non-GIS backgrounds people. And actually, there are many people without intense GIS knowledge using those web applications to building up like the presentation I've been working on. And so you don't need to have programming skills to build up those applications and the maps. And so it can be easy to use if you don't have any GIS knowledge, but you will learn something if you want to have some more advanced analysis functions from GIS. You will definitely need to study on that. But for some basic like display presenting those data on the map, change the color, change the size based on the data in the tables, that should be easy. It shouldn't take long to learn how to do it.
Okay, thank you. Dr. Lin, there's another two questions in your chat box. You see it?
Okay. I see one question says, my URL is blah, blah, blah. Is your map hosted at arcgis.com? Yes. The one I am using now, this is a web application called Story Map. So this is an applications help you to organize your your presentation. So it will pretty much like a PowerPoint slides. So you will be able to drag all those maps as an image to those applications, or you can drag your maps host on ArcGIS Online and to make up this presentation. And you can, what I did was I do all the analysis from on the desktop versions, and then with the result, I publish those map results to ArcGIS Online, and just because you will need to have that hosted on the server to display it in interactive map. So actually, I3, they do charge for storage and some analysis functions online. If you do need to do analysis online instead of using desktop versions, I3 charge for that. If your institution do have the IT department and happen to know how to build up a GIS server, then you don't need to use ArcGIS Online to host your map. And you can just use your local GIS server to host the information and map the interactive map from your GIS server locally. So does that answer your question?
Thank you. There's another one.
Okay.
From, do you see it? Do you feel that GIS currently is best for enrollment management related to projects?
I will say it will be the best. I don't know if I can say it's the best, but it will be a good addition tools to help us to understand, because with the traditional tables and charts, probably not that easy to find out geographic relationships. You may be able to use it will give a good visual presentations, so you will be able to see the relationship directly from the maps. So I would say it's a good addition way to present your data and help you to see something geographically, which you may not be able to see directly from the charts and the tables.
Okay. Some of our members mentioned that, in their institution, the GIS tool is free because they bought a institution-wide license. So
yes.
Maybe you can check with your geographic department to see if it's possible.
Right. Yeah, that's a good point. Some of the universities, especially if you have geography departments or like geology or similar related departments, they may already have the license. So that's good one to reach out to see if you have that license. And also, if you do have those departments, they can possibly have someone able to help you to create those analysis and the maps.
Okay. Any questions? I didn't see any new posting there. So, Dr. Lin, thank you very, very much. We appreciate all your efforts.
Thank you very much for having me.
And this is a Friday, so everybody have fun.
Okay.
And bye-bye.
Thank you. Good job.
Okay. Thank you.
I posted your email address there, so if anyone needs additional information, just send your email to Dr. Lin.
Okay. Okay, thank you.
Thank you.
Thank you.
Bye.